All right, we're on our last example, example 6. I didn't like how I had explained something, so I decided to do this problem for you guys, and that's why the last video stopped at the end of example 5. So let's read through this. It says the figure shows a rope running through a pulley at P and bearing a weight W at one end. The other end is held 5 feet above the ground in the hand M of a worker. Suppose the pulley is 25 feet above the ground. The rope is 45 feet long, and the worker is walking rapidly away from the vertical line PW at the rate of 4 feet per second. How fast is the weight being raised when the worker's hand is 21 feet away from PW? Okay, there's a lot going on here. I think we should just read through this one more time. We'll stop after each thing so we can kind of determine what everything is, okay? So it says the figure shows a rope running through a pulley P and bearing a weight W at one end. The other end is held 5 feet above the ground. Okay, so you guys can see that M is 5 feet above the ground. Suppose a pulley is 25 feet above the ground. Okay, so let's talk about that. So we have this pulley. The pulley is 25 feet above the ground. That's where the 5 comes in, because the actual distance from P to O, which is, you can see a triangle there that we're going to use, is going to be 20. Okay, the reason it's 20 is because the whole thing is 25, but it's 5 feet off of the ground. Okay, so that's 20. All right, so since I can't really write neatly, I'm going to just try that one more time, make it better, because I don't want to get confused. So this is 25, and this is 20. All right, let's keep going. It says the rope is 45 feet long. Okay, so this I think is the trickiest part. You really got to focus. It says the rope is 45 feet long. So there's a lot of lines going on here. Which line is actually the rope? Okay, so the rope is in the guy's hand at M. It goes through the pulley P, and it attaches to the weight W. So the rope is actually this yellow part right here. There we go. Okay. The worker is walking rapidly away from the vertical line PW at a rate of 4 feet per second. So you can see they actually labeled that as dx dt in the problem. And x is the distance between the worker and O. Okay, it says how fast is the weight being raised when the worker's hand is 21 feet away from PW? Okay, so if it's 21 feet away from PW, that is actually our x value. And remember, we do not want to plug that in until the very end. Okay, we want to use that when we're done. It says how fast is the weight being raised? Okay, so let's talk about that part. And so that would be the distance between the weights and the bottom of this triangle here. Okay, that's changing. So as this weight is being raised, that is changing. So we want to give it a variable. I labeled it H because it's like the height of the weight. So I'm going to call it H. So since we're trying to see how fast the weight is being raised, we're actually looking for dH dt. Okay, so clearly we have a triangle here. We are going to use Pythagorean theorem because we're looking at the sides of the triangle, okay? But we have to be really careful because look at the yellow part that I highlighted, the 45. That's not the hypotenuse. It's the distance through P and down a little bit onto the other side. And it's changing, okay? As this guy's walking away, this side right here, my hypotenuse, is actually getting longer. So that is actually a variable as well. And I'm just going to call it Z. Okay. So again, as this guy's walking away, this side is getting longer. It's changing. It's a variable Z. We do not know the rate at which it is changing. So we do not know dz dt. Okay, so that's going to be important for us in just a second. So let's go ahead and try to set up an initial equation that relates these three sides, okay? So we have the red side, that's 20. We have this bottom side, that's x. Again, we're not plugging in the 21 yet. And then we have the hypotenuse, that's z. Okay, so this is what we're going to be taking the derivative of. I do know dx dt. Okay, they gave that to me. It's 4 feet per second. I do not know dz dt. So I really want to replace that z somehow, some way with another variable. Okay, so that's where we're going to come over here now. So let's think about, hang on one second, my kids are being super noisy. I'm going to shut the door. Okay, so we're going to try to relate z to h somehow. Okay, so let's look at the relationship here. We have the 20, that's red. We have the orange, that's h. We have the yellow, that's 45. And we have the black, that's z. Okay, all right. So if we take a z and we add to it the 20, that would be all of the hypotenuse and the 20, okay? So if we just take away the orange, which is h, that gives us what's left is the yellow, 45. Okay, so hopefully that makes sense to you. If it doesn't, rewind, try to listen to that one more time, see if you can make it make sense in your own head. I added the z to the 20, that's the black and the red. I minused off the orange, it gives me the yellow. Okay, so at this point, I'm going to solve for z, and what that's going to do is it's going to give me something to substitute in for z that has an h on it. Okay, so let's see here. I'm going to minus the 20, and I'm going to add the h, so that gives me 25 plus h, and I'm going to replace that into my equation. All right, so now I'm going to take my derivative from left to right. Okay, the derivative of 20 squared. 20 squared is 400. 400 is a constant, so that's 0. I have 2x dx dt. And then over here, chain rule, I have 2 times 25 plus h to the 1. The derivative of h is 1, and then dh dt. Okay. All right, so at this point, I am looking for dh dt. That means I want to have something to plug in for every other variable on this problem, okay? So x, they told me it was 21. dx dt, they told me it was 4. Here's where I don't know something, and that would be the h, okay? But I can figure it out because I know that 20 squared plus x squared, which is 21, is z squared. Okay, so let me solve this. 400 plus 441 equals z squared. 841 equals z squared. Z is 29. And now I can go back up here. Z is 29. That means h has to be 4. So I can plug in a 4 for h. All right, so on the left I get 168, on the right I get 58. Divide by 58 and I get 2.9 feet per second. All right, so that is the last of the examples that I'm going to do with you, and now you are trying, obviously, your homework for 2.12, but also 2.13, which is some extra problems with the related rates.